So we're going to go over the 2008 Calculus BCFRQ question number 5. The derivative of a function f is given by f prime of x is equal to quantity x minus 3 times e to the x for all x greater than 0, and f of 1 is equal to 7. The function f has a critical point at x equals 3. At this point, does f have a relative minimum, a relative maximum, or neither? Justify your answer. So we can go about doing this using the first derivative test. So our intervals are going to be 0, because it's for x greater than 0, to our critical number, critical point 3, and from 3 to infinity. And then what we'll do, we'll plug in values from in these intervals to see what sign f prime of x is going to give us. So let's try f prime of 1. That gives us negative 2, because 1 minus 3 is negative 2, times e to the x. So that gives us a negative number in this interval. And then we'll choose a test value from in this interval. We'll try 4. F prime of 4 is equal to 1 times e to the x. This gives us a positive value. So f prime of x in this interval is positive. And since f prime of x gives us the slope of f, our graph is going to look kind of like this. It's going to go down because it's negative and then turn up because it's positive. So therefore we have a relative minimum. So f has a relative minimum at the critical point x equals 3, because f prime of x, this explanation is important because we have to justify our answer, because f prime of x changes sign from negative to positive. Now on to part B. On what intervals, if any, is the graph of f both decreasing and concave up? Explain your reasoning. So we already found out that f is decreasing on the interval from 0 to 3. Decreasing because f prime of x on that interval is negative. So to test for concavity, we take the second derivative. So we'll take the derivative of the first derivative. Second derivative equals, we'll use the product rule. So the derivative of x minus 3 is just 1. E to x plus x minus 3. And the derivative of e to the x is just e to the x. And we will factor that out. 1 plus x minus 3 x minus 2. And we see here that f double prime has a critical value at x equals 2. A critical number. And now we'll do the same thing we did with the first derivative. We will test the intervals. An easy one here is 1. So we'll do the work down here. F prime of 1 is going to give us e to the x times negative 1. So that gives us a negative value. F prime, let's try 3. F prime of 3 gives us positive e to the x. We get a positive value. So since f double prime is negative on this interval, it's going to be concave down. And since f double prime is positive on this interval, it's going to be concave up. Therefore, let me move this over. Therefore, since we're trying to find where it's both decreasing and concave, well, it's concave up on 2 to infinity, and it's decreasing on 0 to 3, so the intersection of those two would be 2 to 3. So f is decreasing and concave up on an interval 2 to 3. And our justification for this is because f prime of x is negative on the interval, and f double prime of x is positive on this interval. Now on to the last part, part C, find the value of f of 3. Now to find f from f prime of x, we just need to integrate f prime of x. We'll take the integral of x minus 3 times e to the x dx. Since we can't integrate this off the bat, since it would be kind of hard to do that, we're going to use integration by parts. And the formula for integration by parts is u times v minus v times du. And we can use a chart to help us visualize that. U, du, v, dv. And then the next problem is we need to find out which function, x minus 3 or e to the x, to use for u, or which to use for v. And what we can use to figure that out is this little acronym LIATE, which will give us the priority of which function should be u. So on the top we have logarithmic, then we have inverse trig functions, then algebraic functions, then regular trig functions, and exponential functions. So what comes first is algebraic, because e to the x is an exponential function. So that means our u is going to be x minus 3, and our dv will then be what's left, e to the x. So the integral of e to the x is just e to the x, so v will be e to the x. And the derivative of x minus 3 is just 1. So now we'll plug in these values into the formula. So this whole thing here equals quantity x minus 3 times u times v, so x minus 3 times e to the x, minus the integral of v, which is e to the x, times du, which is just 1. So this is what we have. And then to integrate this, the integral of e to the x, like we said here, is easy. It's just e to the x. So this equals x minus 3 e to the x minus e to the x. But this isn't our answer because it's asking us to find the value at 3, and it gives us an initial value here. F of 1 is equal to 7, so we'll add 7 here on the outside, and then we'll evaluate this whole thing from 1 to 3. So we'll plug that in. 3 minus 3, so this is 0. Then we get negative e to the 3. Then plugging in 1, we'll get negative 2e to the 1 minus e plus 7. So our final answer will be negative 3 minus negative 3e plus 7. That's just e to negative 3 plus 3e plus 7. For more practice, you can look up Paul's online math notes or Visual Calculus. They have a really good array of integration by parts problems that you can use to get more familiar and more comfortable with the topic. Thank you for watching.